A while back, I saw a motorized microphone mount that allows you to move a microphone remotely side to side, front to back, which is kind of cool for putting in front of like a guitar cabinet or something like that. So when you're in the control room, you don't have to run in there and change microphone position. You can do these tiny little movements back and forth, front and back. And when I looked at the price on these things, I was like, that is like way outside of most people's budgets. So I decided to DIY something. Um, and where I got with it is I just have a single 2020 extrusion with a linear rail on it, and the microphone moves back and forth with the stepper motor. I don't have it set up for like, remote access or anything like that, although I am using an ESP32 board that has Wi-Fi and whatnot on it. But I don't really have a use for this thing. So I am just going to start releasing all of the STL files and where I'm at with the code, which isn't really far at all. Basically, I can move the thing back and forth, and that's about it. What I'm running into right now is with the stepper driver I'm using, I get a little bit of whine in the motor, but if you're putting this thing in front of a guitar cabinet, that thing, you're gonna have so much buzz coming out of the speaker anyway, you're not really gonna be paying attention to the whine that's coming from the motor. But in the description below is going to be links to all of the files, how to build it, whatnot. And I'll do a quick run through of what this thing is. So this is the motorized microphone mount. We've got our 2020 extrusion back here. We've got a linear rail up top. Got a motor mount with a limit switch connected on back. And we've got our idler pulley mount over here. Limit switch connected to that. All these parts are 3D printed, and there's a 3D printed mount to mount the extrusion to a microphone clip. You can get a microphone clip on Amazon, take it apart, and 3D print this piece, and yeah, it all just slaps together really easy. But let's do the homing sequence. So, and here's my ESP32 and driver board. Just going to reset it so you can see the homing sequence happen. So it's going to go and hit the limit switch, and then it's going to move to center. So this thing is homed, it knows where it is in space. If you were to hit this limit switch or this limit switch, it will stop and it won't grind or do anything crazy like that. I don't even have buttons hooked up at this point. I'm just shorting leads together. This would be a button that shorts to ground. Let's see if this thing moves. You can see it making tiny little movements. It's like barely going because that's how I have it set up in the software right now. Because ideally, if you had this in front of a speaker, you're not going to be making big movements. But let's see, does that move the other way or is it this one? There we go. Short this one to ground. That's the same one. Let's see. There we go. Now we're going the other way. In the code, it would be really simple to either have a push button that can toggle through step distances or a potentiometer, something like that. That way you can do like big movements with it, micro movements, whatever. So this is where we're at with it. It works great. It's got a tiny little bit of motor whine. Let me see if I can pick that up on my lav here. Sorry for the noise. I wonder if you can hear it. Either way, this is the project. Assembly is super easy. All right, I'm just going to do a quick disassembly of this thing. Instead of doing an assembly video, you just watch it in reverse. You'll be fine. It's not that complicated. All right, so we've got an A25D mic clip. This is from Shure. Comes with your SM57, your SM58. It's got flathead screw and a flathead screw. Just two flathead screwdrivers in there, and you're good. You want to make sure this is nice and tight because this thing is heavy. So this is the 3D printed mount. Let's take that off real quick just to show you how it's mounted. And I should probably grab calipers. You know what? I'm unplugging all of this. We don't need this. All right, so this is my simple little driver board that I whipped together. ESP32 has an antenna, so you can control it remotely. This is a DRV2885 stepper driver set up for 1/32 micro stepping to keep it nice and quiet. And let's see. So This makes it a little easier. We've got our two micro switch board, or not micro switch, limit switch boards here on back. So when microphone goes over, or this carriage goes over, it hits that switch, hits that switch. I am going to grab some calipers so we can just measure some things so you know what to buy, so you have a bill of material. But that'll be in a second here. All right. Start taking this thing apart. Yep, that's not right. Let's see if this one's right. That one's right. Okay. That one's out. And this one's out. So what you've got is 3D printed part, a 25D mic clip that was taken apart using the screws from the mic clip. Let's see if we can get these to pop out so we can measure them. I believe this is, I know this is an M5, but I believe this is a M5 10mm. Let me grab my calipers. If only I knew where my calipers were. All right. So we have got my cheap Harbor Freight calipers. So M5 by, what is that? 10. So yeah, M5 by 10mm. I can't see the camera, so hopefully you guys can see what I'm doing because it's up in the air over my work desk. But yeah, M5 10mm times 2. Write that down. And then you have these, I don't know, what do they call them? They're not like T-slot nuts. They're like extrusion nuts. Get them on AliExpress. I think they have them on Amazon. I'll find the link to where I bought them from and I'll throw it in the description. But so 2 of those. Let's pop this out of here. Come on. My tolerances are pretty tight on my printer. All right, so we've got 2 M5s, 2 nuts. Let's take the motor out. So these are M3 screws. I didn't have the correct length because they bottom out pretty quick in my stepper motor. So that's something you're going to have to mess around with because every stepper motor I've used has had different length screws that you should use with it, but they're always M3. At least the ones I've dealt with. So this is like a pancake M3 or a pancake 12-volt stepper motor with a GT2 pulley. I think that's a 20-tooth pulley. Amazon for both of these things. Again, links will be in the description. Nice and cheap. So because I didn't have the right length, I just threw some M3 nuts on these. So we've got our belt, another Amazon or AliExpress thing. Is it AliExpress or I don't know. But anyway, we got some more M5 hex screws here. Let's see if that was, and more of these nuts. So you want to add that to your list. And I believe these are also, where did I put that? There we go. I believe these are also 10mm. Come on. Yeah, these are 10mm as well. So you've got 2 more of these nuts and 2 more M5 by 10mm. What are these called? Button head, button cap, button something, I don't know. Again, very easy to find, very cheap. And then custom limit switch board, limit switch. I had a pre-made cable with one of these JST XH connectors on it. This is a M3 screw, self-threading. You can do whatever you want. You can put a heat insert in there, it doesn't really matter. And there's a second hole here, but there's a little nub when you take this off. I'm not going to do that. But there's a little nub that goes through this hole just to keep this thing lined up, and that's what tightens it down to hold it on. All right, so this is also a 3D printed part on here that holds the belt on. Wonder if I can pull it off. There we go. So yeah, this little 3D printed thing. It's got some grooves in it to hang on to the belt. When you thread the belt through, around the pulley. So what you would do is you would put this through, get the belt all the way around, pull the belt as tight as you possibly can with the motor loose, so it's pulling in this direction. Pull that that belt really tight, clip this thing on as close as you can, push it down in there, and then there's actually slots inside this mount so you can get your extra tension by pulling your motor away, tightening it down. I was going to do something over here where you're actually moving the idler pulley out, but this was a lot easier to do in FreeCAD. And again, FreeCAD files will be available for you guys to run with this. All right, let's see what else we got. So, linear rail. This is a MG12 something or M12GH. We'll figure it out. I'll get it correct in the description. This is what? This is unwieldy is what this is. This is 200 millimeters in length. And the extrusion itself is what? 250? Yeah, 250. So a 250 millimeter 2020 extrusion, 200 millimeter MG12H, MHG something. All right. So this is a threaded microphone adapter, got it on Amazon. These are just M3 screws. We'll figure out the length here in a second. This is another 3D printed part. This isn't the most elegant solution. This was just me having an idea and wanting to whip something together as fast as possible. All right, so let's get this belt out of the way here without throwing these screws all over the place. There we go, belt's out of the way. And this is 4 M3 screws. Okay, these are shorties. Let's see. They are about, what is that, M3 by 5 millimeters? Something like that. There's play there. It's not a super tight tolerance. Now this screw, I forget what the dimensions are of these screws, but it's a set thing. And now the landscapers are here, so that's awesome. I ended up going to the hardware store for the screw. Let's see, what is it, like a 5/16? Does that even make sense? I know it's not metric. Approximately 6 millimeters, but it's not metric. This thing is about 12 millimeters tall, or ½ inch. Yeah, so ½ inch. You want it to have this chamfer because the mount itself is chamfered, and you want this to sit as flat as possible so you don't have your thing sitting in the air on top of your carriage. Now, I don't want this carriage to come off of here and spit bearings all over the place, but I don't have any tape at my disposal, so we'll just be careful. But again, M5, 10 millimeter, T-nut. So what are we at here? We're at 1, 2, 3, 4, 5. 5 nuts and 5 M5 screws, and last one. All right, and this is M5 as well, with an M5 locking nut. Let's just measure the length on this thing. This thing is, so it's an M5 by, where are we at here? 5 by 24, does that make sense? It's probably 25. Yeah, so M5 by 25 with an M5 locking nut, idler pulley. Again, links will be in the description. Last thing is we've got M3 screws that hold this linear rail on. I think I have it like every other one or something like that. It's not crucial that you put it in every single one. And then it has 3mm of these type extrusion nuts that are in there. So that's that. This thing is very, very easy to assemble. Takes a few minutes. Very little hardware. All standard stuff you can get pretty much anywhere. You can literally get all of this on Amazon. The screws would be a little bit more expensive because they come in kits and not singles. Probably easier to order from AliExpress. There are tariffs now, so I don't know. Whatever you want to do. But thanks a lot. I hope you guys build this thing. I hope somebody downloads the code and actually makes it good, because I just have it so it's functioning. I just wanted to run with an idea and then ran out of time for it. So hopefully you guys can do something with it. Keep me in the loop, send me messages, comment on the video, whatever. I'm happy to help out any way I can. Thanks, guys.